Hello everyone. In this session, today we are going to discuss about TCP/IP. Overview of TCP/IP architecture. TCP/IP means Transmission Control Protocol and Internet Protocol. It was developed by the Department of Defense Project Research Agency ARPA, later DARPA, as a part of a research project of network and interconnection of connect remote machines. It is the network model used in the current internet architectures as well. It is one network model that is used in the architectures. Protocols are the set of rules which govern every possible communication over a network. This protocol describes the movement of data between the source and the destination or the internet. They also offer simple naming and addressing schemes. TCP/IP architecture. The architecture of the TCP/IP. The OSI model we just looked at is just a reference model. It is a logical model. That is a logical model. It was designed to describe the function of the communication system by dividing the communication procedure into smaller and simpler components. But when we talk about the TCP/IP model, it was designed and developed by Department of Defense in 1960s, and it is based on the standard protocols. Already I told you, it is a set of rules. IP stands for transmission. TCP/IP stands for transmission control protocol or internet protocol. The TCP/IP model is a concise version of OSI model. It contains 4 layers, unlike 7 layers in the OSI model. In the OSI model we have 7 layers, but in the TCP/IP model we have only 4 layers. That is application layer, transport layer, internet layer, and the network layer. Application layer are also called process layer, host to host, transport layer, internet layer, network access or link layer. The comparison of the TCP/IP and the OSI model. How it is differ from each other. Here, TCP refers to the Transmission Control Protocol. OSI refers to the Open System Interconnections. TCP/IP has 4 layers, but the OSI model has 7 layers. TCP/IP is more reliable, OSI is less reliable. TCP does not have very strict boundaries, but the OSI has strict boundaries. TCP/IP follow horizontal approach, OSI follows a vertical approach. TCP/IP uses both session and presentation layer in the application layer itself. OSI uses different session and presentation layer. TCP/IP developed protocols, then model. OSI developed model, then the protocol. Transport layer in the TCP/IP does not provide assurance of delivering the packets, but in the OSI model, the transport layer provides the assurance of the delivery of the packets. TCP/IP model network layer only provides connectionless services. Connectionless and connection oriented, both services are provided in the network layer in OSI model. Protocols cannot be replaced easily in the TCP/IP model while in the OSI model it is easy to replace with the technology. So these are the comparisons of the TCP/IP with the OSI model. The diagrammatic comparison of the TCP/IP and OSI model. That is, the transport layer in the TCP does not provide assurance of delivering the packets, whereas in the OSA model, transport layer provides the assuring of the delivery of the packets. TCP/IP model network only provides connectionless service. Here, connectionless and connection-oriented both services is provided by the OSA model. Protocols cannot be replaced easily in the TCP/IP, while in the OSA it is easy to replace this with the any technology. So this is the diagrammatic difference of the OSA model and TCP/IP. Here we have seven layers, that is application, presentation, session layer, transport layer, network layer, data link layer, physical layer. Whereas in the TCP/IP model we have application layer, transport layer, internet layer, network access layer. This is the diagrammatical comparison of the TCP/IP model with the OSA model. Next heading is TCP/IP layering. What are all the layers that will come under in the TCP/IP? First one is application layer. This layer performs the functions of top three layers of the OSA model: application, presentation, and session layer. It is responsible for node-to-node communication and controls user interface specifications. HTTP and HTTPS. HTTP stands for Hypertext Transfer Protocol. This protocol, it is used by the World Wide Web to manage communication between the web browsers and the web servers. HTTP, it is a main protocol, so that is used to manage, it is used in the www to manage the communications between the web browsers and the web servers. SSH. SSH stands for Secure Shell. Secure Shell. It is the it is the termination of the it is the terminal emulation software similar to Telnet. NTP. NTP stands for Network Time Protocol. It is used to synchronize the clocks on our components to one standard time source. In the HTTP, so this is responsible for node to node connection, and it is the combination HTTP, it is the combination of HTTP with SSL, that is secure socket layer. It is very efficient in cases where the browser need to fill out the forms, sign ins, authentications, and carry out the bank transaction. There we will use the HTTP protocol. Whereas in the SSH protocol, the reason SSH is more preferred because it has the ability to maintain the encrypted connection. It sets up a secure session over the TCP/IP connection. And whereas in the NTP, that is Network Time Protocol, it is very useful in situations like banks transactions. Assume the following situation without the presence of the NTP. Suppose you carry out a transaction where your computer reads the time at 2:30 p.m. while the server records it at 2:28 p.m. The server can crash very badly if it's out of synchronize. So that is why this is morely used in the synchronized purpose in the bank's transaction. This is about the application layer. Next, second one, host to host layer, or it is also called transport layer. This layer is analogous to the transport layer of the OSA model. It is responsible for end-to-end communication and error-free delivery of data. It shields the upper layer applications from the complexities of the data. The two main protocols present in this layer are, one is TCP and UDP. TCP is transmission control protocol. It is known to provide reliable and error-free communication between end system. It performs sequencing and segmentation of data. It also has acknowledgement features and controls the flow of the data through flow control mechanism. It is very effective protocol but has a lot of overhead. Due to such features, increased overhead leads to increased cost. Next type of protocol is UDP, that is user data protocol. On the other hand, does not provide any such features. It is a go-to protocol if your application does not require reliable transport, as it is very cost effective. Unlike TCP, which is connection oriented, UDP is connectionless. That is about the transport layer in the TCP/IP. Next, third layer is internet layer. In this layer parallels the function of the OSS network layer. It defines the protocols which are responsible for logical transmission of data over the entire network. The main protocols residing at this layer are IP, ICMP, ARP. What is IP? IP stands for Internet Protocol and it is responsible for delivering the packets from the source host to the destination host by looking at the IP address. By looking at the IP address in the packet headers, it will transfers the data. It will delivers the packets from source host to the destination host. IP has two versions. IPv version 4, IP version 6. IP version 4 is one that the most of the websites are using currently. But the IP version 6 is growing as the number of IP version 4 addresses are limited in the number when compared to the number of users. That is about IP. Next, ICMP. ICMP stands for Internet Control Message Protocol. It is encapsulated with IP datagrams and it is responsible for providing hosts with information about the network problems. Next one is ARP. ARP stands for Address Resolution Protocol. Its job is to find the hardware address of a host from a known IP address. ARP has several types: reverse ARP, proxy ARP, gratuitous ARP, inverse ARP, etc. This is about internet layer. Next, last one is network access layer. Network access layer, this layer corresponding to the combination of data link layer and the physical layer of the OSA model. Whatever the functions that performed by the data link layer and the physical layer, it combines the both. It looks out of the hardware as addressing and the protocols present in this layer allows for the physical transmission of the data. We just talked about ARP being a protocol of the internet layer, but there is a conflict about declaring it as a protocol of the internet layer. As the network access of the layer, it is described as resides in the layer 3, being encapsulated by the layer 2 protocol. Next, so these are the four layers of the TCP. So as you can see in the diagram also, we have a application layer, transport layer, network layer and the interfaces, and this is about the TCP/IP. In this session, we discussed about the overview of the TCP/IP architecture and what is the TCP/IP architecture and the comparison of the TCP/IP and the OSA model and the diagrammatical comparison of those two models and TCP layering, how many types of layering are there, application layer, or transport layer, internet layer and network layer. This is about this session. Thank you.